UCR team, you're gonna want to laugh at us. So, all right.
I like team average height for like 6'1".
Gosh, it's okay. It's not the size of the dog in the fight; it's the size of the dog fighting the dog. So, and all those other things. Dynamite comes in small packages. All that other stuff. That's what I'll keep telling myself. All right, so here we go. Solving equations. All right. Again. So the first thing I want to clarify is kind of like a bad thing that I did for you guys on Friday. I should have been more careful or more, with having you guys follow the directions in the book, because with what the book, has you do. I told you only worry about between 0 and 2 pi, where in the book, they did ask you to do both only between 0 and 2 pi, but also in general. So we're going to solve some of these problems just kind of generally speaking without only restricting ourselves to be between 0 and 2 pi, and just see what happens. The change isn't that big of a deal. It's not like that hard of a change to make, but just so we can have that under our belts too. So, for example, let's say we want to solve the equation for x. Alright, solve the equation for all possible values of x, I should say. Solve the equation for all possible values of x. Okay. Alright. So, and we'll start with a bit of an unfamiliar problem here too, maybe. Okay. So this trig function here, or this trig equation, I should say, sorry, this trig equation, at first glance, right, it's like maybe not so clear about what to do. It doesn't really match any of the ones we've done before. We can't combine the two signs, for example, because one sign's squared and one is just plain old sine. All right. We also can't really, we don't have a GCF here. I mean, yeah, these two have a sign in common, but this one does not. And so if we pulled a sign out of this, we still have that -4 to deal with, and we wouldn't be able to set things equal to 0, use that zero product property or anything. But upon closer inspection, right, if we look at here, we've got, well, this is really, remember, sine squared of x is really just quantity sine of x squared, plus 3 times that same exact quantity, sine of x, and then -4 equals 0. So, in other words, we have something squared plus 3 times that same something, -4 equals 0. And so how might we be able to solve this? What could we potentially do here? Yeah, factor it, like it's a quadratic. In fact, it's basically a quadratic here. So yeah, so we need a sine of x times the sine of x to make that sine squared of x, and then we need to come up with two numbers that multiply to make what in this case? -4, and add to make what? 3. Okay, so what would those numbers be?
-2 and -1.
So that would not, they would add, nope. So yeah, sorry. Okay, so it's gonna be +4 and -1, and that's 0. Okay. -4 and then +4 and then -1 there. Yes. Okay. And so now we have two things that multiply to make 0, so we can set each one of those two things equal to 0. Each one of those factors equal to 0 by the zero product property, and we get sine of x equals -4 and sine of x equals 1. Okay? Then we just solve. When does sine of x equal -4? That's right, never. Never. Okay, so we don't have to worry about that. And then sine of x equals 1 when x is what? pi over 2. Right? Pi over 2. Now, that would be our answer if, that would be our only answer if the direction said solve the equation for x such that x is between 0 and 2 pi, right? Or solve for all the solutions between 0 and 2 pi. But here this is saying solve for all possible values of x. So we need to also, in addition to putting pi over 2, we should be able to add what to this and still get a solution? 2 pi, right? So, but rather than having to say, well, I could add also 4 pi, or I could add 6 pi, or 8 pi, or I could subtract 2 pi, or subtract 4 pi. Rather than having to do that, the way we take care of that is writing that 2n pi that you maybe saw, or 2 pi n, I forget how they wrote it in the book. Something like that, okay? If you look up your answers in the back of the book, for the problems where it did not specify the directions between 0 and 2 pi, this is how they took care of that. Pi over 2 plus 2n pi, and the only other thing we should really say is that n, okay, is an integer. Okay, it's not just any multiple of 2 pi, or it's not just any multiple of 2 pi, it's 2 pi where 2n pi where n is an integer. Okay, and we should write that out every time we answer the question, right? So if you don't want to have to write out that little phrase, there is like a nice mathematical way to do it, like with symbols and stuff like that, okay? So rather than writing n as an integer, you can do this, n, okay? And then you write what looks like basically a little e. It's almost like a c with a little e there, okay? N, and then that kind of funny e. And then you write the symbol for the integers, which is a z with like a double line there, okay? So this is the alternative way to write n as an integer. This reads n is an element of the integers. N is an element of the integers. Rather than having to write the phrase n is an integer. If you take like more math classes, like in your college career or something like that, you know, the more you take, the more likely you'll see symbols like that used. Okay. So n is an element of the integers. So that is our final answer. Right there. Okay.
So why would it be plus 2 pi?
Why plus 2 pi?
Yeah.
So the idea is coterminal angles, right? Sine, the function sine, repeats itself every 2 pi.
Oh, I see.
So we add multiples of 2 pi, or subtract multiples of 2 pi. Okay. So let's try another one here. Let's solve the equation, again, for all possible values of x. Okay. Solve the equation for all values of x, and our new equation here will be tangent x times sine squared of x minus tangent x times sine of x minus 2 tangent x equals 0. Okay. So, with the way that this one is currently written, how might we go about tackling this problem? What do we think here? Are there like terms here? That would be something we would want to do, but if you look, this one is tangent sine squared, this one's tangent sine, so not exactly.
I wrote mine way down.
Oh, okay, got you. Yeah. So, Brandon, what can we do there? What do you say? Yeah, so if you look here, all three terms of a tangent, let's factor a tangent out. We have a GCF there. This one we can do that. We're left with sine squared x minus sine x minus 2. And then, yet again, we see that sine squared x minus sine x minus 2. Maybe factor that, right? Like a quadratic. So let's see if we can. Let's see here. We'll need a sine of x, and then another sine of x. So we need two numbers that multiply to make negative 2, but add to make negative 1. So it'll be negative 2 and positive 1. And now at this point we can set all those factors equal to 0. So you can say, okay, tangent x equals 0. Sine of x minus 2 equals 0. Sine of x plus 1 equals 0. Okay. So, tangent of x equals 0 when x is what? Tangent of x, yep. 0 and pi. 0 and pi, exactly right. Okay. Sine of x equals 2 when that's right, never. Okay, sine of x equals -1 when x is what? 3 pi over 2. 3 pi over 2, or 3 pi halves. Okay, question? Yes, you could, but we want to be careful here. So again, if the problem said solve the equation for solve the equation for x between 0 to 2 pi. So Tyler, if the directions were like restricting our solutions and just said solve for all the possible values between 0 and 2 pi, then yes, we would have 3 answers, 0, pi, and then 3 pi over 2, those 3 answers. But the directions don't restrict here, and so we do want to obey those directions and not, just do like this, forget about them. Okay, we do want to follow that. We want to solve for all possible values, which means that x equals 0 is a solution, right? X equals pi is a solution, and x equals 3 pi over 2. Okay, but we have to remember, right? For example, sine repeats itself every 2 pi. So that 3 pi over 2 answer, if we add multiples of 2 pi, okay, if we add multiples of 2 pi, then that will still be a solution. So that's going to be one possible solution there. Okay. Now here's something we got to be careful about, right? Tangent. What's the period for tangent? How often does tangent repeat itself? Every what? Every pi. So here we're not going to add 2n pi to x equals 0 and x equals pi. We're going to add pi to those two. So it'll be plus n pi plus n pi. Okay. Right. Tangent repeats itself every pi. So when we solve a trig equation with tangent and we're trying to list all those possible solutions, okay, make sure you're adding by n pi, not 2n pi. Cosine and sine repeat every 2 pi. Right, their period length is 2 pi. It repeats every 2 pi. Tangent was every pi. Now, if you look at those two solutions for tangent, they're pretty much saying the same thing. Right? You take 0 and you add multiples of pi, that means you could have 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, or -1 pi, -2 pi, -3 pi. But the same thing with starting with pi. If you start at pi and add or subtract multiples of pi, it's the same thing. So you don't, it's kind of redundant to say both things. If you wanted to, you could say the answer was just this and this and be done, because that second one's kind of redundant. Okay, not kind of, it is redundant. Okay, you don't need to. These two are saying the same thing with that plus n pi piece in there. Okay, so just for thought. Food for thought there. Questions on anything yet? Here. Isn't 0 the same as 2 pi? Yes.
So if I wrote 2 pi,
if you wrote 2 pi, not a problem, yeah. If you wrote 3 pi, 4 pi, 5 pi, whatever you wanted there, it would be the same thing, because you wrote that plus n pi there. The only thing I'm going to warn you about, right, is when we have directions like we did in the warm-up. Okay. We have directions like we did in the warm-up. Right, it says solve the following trig equations from 0 to 2 pi, not including the 2 pi. So that means you would need to use the 0 there as your solution, not the 2 pi. I wouldn't count it because it's not including 2 pi. Okay, so just be aware of that. Okay, so let me have you guys try one then, if there are no other questions. So solve this one. Same directions as those previous two that we did. So 2 cosine squared minus cosine x minus 1 equals 0. Okay, whoops, sorry, it's off the screen. There you go. 2 cosine squared x minus cosine x minus 1 equals 0. I don't think that's the coefficient for you. You can add the 1 over, yes, but if you divide by 2, you would be dividing the entire side by 2. So it's like, it's difficult to get divided by 2. Yeah.
Yeah.
Hands up. Okay.
This? Yep. You know what I got? Yep. Now you I think though this is going to give you, I think that should be minus 1, that should be plus 1. So it'll give you plus 2 and then minus 1. It'll be negative 1 and give you
Oh,
positive.
right, right.
What is it what? Sorry, go ahead. It's no, it's 2, 4, 5. Yeah. Yeah, 5 over 3. It would be positive because that's the formula.
Oh, yeah.
So, are you familiar with the reference triangles?
Yeah.
Okay. So, you have cosine of x equals negative 1/2, right?
Yeah.
Okay. So, we're going to use this triangle. Okay. Cosine is adjacent leg over hypotenuse. So, cosine, for example, if I just randomly pick, cosine of pi over 6 would be root 3 over 2. That's not what we want. So it's pi over 3. Okay. You want negative 1/2 though. So you want the pi over 3s
That's
in the second and third quadrant. Yes. Yes, because you want your sign to be correct there. So right now what you're going to have is 2 cosine times 1, so it'll be positive 2 cosine, minus 1 cosine. So it's 2 cosine minus 1 cosine, that gives you positive 1 cosine. You want negative 1 cosine. You say Caleb what? Or Alex?
I don't know. I expressed that on
Just find out.
Okay, question.
Oh, you want to hang back with this?
So if you're having trouble, like if you're like looking at it like, the cosines are throwing me off, feel free to rewrite it. Say 2x squared minus x, or minus x minus 1. Calculate subtract. Okay, great. So you know we need 2x and an x, right? So what numbers are we going to move?
Sorry, I'm having a brain burn.
That's okay. We need to multiply the negative 1 and add the negative 1.
Oh yeah. Oh, okay. So.
So just tell me what multiplies negative 1. Alright, so let's just put a plus 1 here and a minus 1 here. Okay, alright, that'll multiply. So let's just check to make sure. Positive 1x minus 2x. That's right. But of course, we don't have x here in cosine. So either cosine. Replace x in cosine.
Yes, but cosine does I know the experiment, is that right?
It should be 2 pi n. You only want to add pi n when it's tangent repeat of pi. So the factoring is right, but cosine x, so this will solve the cosine x equals 1. Cosine x is equal to pi. That's negative 1. That's what that's pi cosine x is equal to. Alright, we're good. I think we. Close. The 2 should be in with the cosine. Again, when you pull.
Oh wait.
That would, yeah. Oh, wait, hang on a second. I see what you're saying. Hang on. Yeah, see, the problem is, if you have, like you redistribute that, it's going to be 2 cosine x minus 2. That minus 2 and that plus 1 will find like negative 2, right? Which you need a negative 1 there. So what I'm saying is the 2 should just be with the cosine. Like, if you have it outside the parentheses, it should be 2 cosine x minus 1 times cosine x plus 1. Well, okay, go ahead, write it down. So yes, the idea is it's 2 cosine x 20 squared. So we need a 2 cosine x squared. So 2 cosine x times cosine x will result in 2 cosine x squared x. And then 2 times 1 is 2 cosine x minus 1 cosine x. Uh-oh, we need a negative cosine x. That gets us positive. Then, okay. All right. So this is, here's what we should have, where we should have arrived. Okay. So there are your answers. 0 plus 2n pi, where n is an element of the integers. X equals 2 pi over 3 plus 2n pi, and then also x equals 4 pi over 3 plus 2n pi, where n is an element of the integers. Again, because we are not restricted between 0 and 2 pi. If we were restricted, if it just said solve for all x values between 0 and 2 pi, you would just ignore those plus 2n pi's. And you'd have all you needed right there. Okay? Question on any of that? All right. So, one more thing I want to show you here. One more thing I want to show you. Okay. And that is. Whoops, I don't know why I'm writing it right here. And we'll do this for all. Solve cosine of 3 theta equals 1/2 for all values of theta. Okay. So, whoa, this is different, right? We have not seen any trig equations where we have that 3 theta inside, like some number inside the trig function. Right? It's always just been plain old cosine theta or sine theta, tangent theta, whatever. There's been stuff outside that they've had that's been affecting them, but nothing inside. So how do we deal with this? Well, the way we're going to deal with this, bless you, is we're going to kind of ignore the 3 theta to start things out. We're just going to say to ourselves, okay, cosine of what gives us 1/2, right? Cosine of what gives us 1/2, all right, which is a question we can answer, right? Cosine of pi over 3, or sorry, not pi over, yeah, cosine of pi over 3 gives us 1/2, and also cosine of 5 pi over 3 gives us 1/2. So we know that whatever we have here, our what has to equal pi over 3 and 5 pi over 3. Okay. But of course, we don't have a question mark inside the parentheses there. What's inside the parentheses? It's 3 theta. So that really means that that 3 theta has to equal pi over 3, 5 pi over 3. And of course, if we want more solutions, we're going to be adding that 2n pi as well. Okay, right, we're going to be adding that 2n pi as well there. So then if 3 theta is equal to that pi over 3, 5 pi over 3, the plus 2 pi n, okay, what do we do to just get theta here? Divide by 3. Exactly right. So we'll divide everything here by 3. Which means that theta is going to be equal to pi over 9, 5 pi over 9, and then not plus 2 n pi anymore, it's going to be plus 2/3 n pi, or 2 pi over 3n, you know, however you want to say that there. Again, where n is an element of the integers. Okay, I'm going a little crazy with my commas there. Okay, and then that will be our solution. So you still solve it like you normally would, right? We have the trig function down to just cosine. We figure out when cosine is equal to 1/2. That was at pi over 3 and 5 pi over 3. But again, we're not interested when just cosine is equal to pi over 3, 5 pi over 3. We want to know when then 3 theta, when 3 theta is equal to that pi over 3 and 5 pi over 3. Yes?
Why is it not negative 1/2? Oh, never mind.
Yeah, that's just what the problem is set up that way. It just started with positive 1/2. So, okay? So there's the pi over 9, the 5 pi over 9, and the 2 pi 3, or 2/3 n pi. Okay? So, this should not surprise us too much if we think back to our graphs of the trig functions. For example, cosine, when you had this number inside with the theta, you remember what we did with that, right? We took that 3 theta, we put it between 0 and 2 pi, we divided both sides by 3, and what did that do? Our original period from 0 to 2 pi shrunk to be from 0 to now 2 pi over 3. Okay? And so rather than repeating every 2 pi, cosine of 3 pi repeats every 2/3 pi. Okay, every 2/3 pi. And so those values, pi over 3 and 5 pi over 3, they also must shrink down by 1/3, pi over 9, 5 pi over 9, you know, as a result as well, their locations, because of that 3 theta there. Okay, it shrinks everything back. So that's why we have those points.
It's a situation where there's the same period, so it's the same coefficient multiplier. We can just write it. We don't have to write plus 2 pi every time. We can just like put a
Something like this.
Yeah.
Yeah, this is fine. Yeah, just to, yeah. I mean, I know, because it's like a lot to like write out, and you want to like try and find the most efficient way. So I would be fine with something like this. Yeah. I don't know. It's like kind of not right, because the way I've written it here, it kind of implies it's just the 5 pi over 9 that's adding the 2 pi n over 3 and not the pi over 9. So maybe I should put like parentheses here or something like that, and then it's like plus 2/3 n pi. Maybe that would make more sense. I don't know. But now like this just looks like ridiculous. All these like symbols thrown in there. I don't know. So, but yes, you do want to indicate that it's really both these things are adding the 2/3 n pi too. So that's all. All right. Let's try one more here, and then I'll have you guys try one on your own. Yeah, we'll do a tangent one. Okay, so let's solve 3 tangent of x over 2 plus 3 equals 0. So Holly, what should we do here to start this thing off? Subtract 3 and then? Yeah, so we'll end with tangent of x over 2 equals negative 1. And let's see, when does tangent of x over 2 equal negative 1? Do you remember? This is a bit trickier. So we can use our reference triangles actually. Tangent of pi over 4 gives us positive 1. So we need the pi over 4s in, well, we need it to be negative 1. So let's see here. So it can't be in the third quadrant because tangent's positive there. It won't be in the first quadrant. So we need the, what's the pi over 4 here in the second quadrant? What's that? 3 pi over 4, 3 pi 4s? And what about the one here in the, yeah, 7. Yeah, exactly right. So, again, when does this thing equal that? Well, x over 2 will then equal the 3 pi over 4, the 7 pi over 4. Okay. And then it's also plus n pi, not 2n pi, right? Not 2n pi. Tangent repeats every pi, not 2 pi. So that's why you need only the n pi there. And so to finish solving, we'll multiply through by 2. So this side times 2, and this side times 2. And so you get x equals 3 pi over 2, 7 pi over 2, and then plus, well, now it happens to be 2n pi, because of the way we solved it there. That's how it's solved out. And again, I guess both these answers are kind of redundant because 3 pi over 2, or 7 pi over 2 is 2 pi away from, so you really could just say 3 pi over 2 plus 2n pi there if you wanted to. Or you can list them both, it doesn't matter. But you could just say the 3 pi over 2 plus 2n pi, and that would include 7 pi over 2. Or you can just include, say, 7 pi over 2 plus 2n pi, and that would also include 3 pi over 2. Either one. You don't actually need both of them there. So. All right. Questions on that? I'm going to have you guys do one more, and then I'll get you guys started on your thing. So we're all good there? All right. So try this one here real quick. Just make sure we're all good. And then I'll give you your assignments. Okay, so go ahead, give that one a try. I'll answer the phone. Hello? Sure can. Uh-huh. Bye. Shelby. You don't have to look so happy to leave math class, Shelby. You could be sad if you want. It's okay. No, it's all right. Very good. Let me put the assignment up then here for you, Shelby, real quick, so you can have that. It's gonna be page 394, numbers 33, 39 to 41. Oh, 39 to 43. 63 to 91. That's all odds. Let's do the odds. No problem, Shelby. We'll see you. draw the upper one again.
Yes, the only thing I would say is square root here, plus or minus, so you want to include all of them. But whatever you got, what you do have here is, oh, and then also this would also divide by 2. Not only, but the period also divides by 2, so it should be n pi. So this will not cancel out that because it's inside out. So you want to, and again, square roots would have plus or minus here. So you want to really just figure out what side of what gives us plus or minus 2. Multiply it through, right? 2t equals those answers plus 2t.
Okay. So here is what we should end up with, right there. Okay. Get the trig function by itself. So we have sine 2t ends up being plus or minus root 3 over 2, right? When we square root there, plus or minus, okay, because it's an equation setting. And then, sine of what gives us the plus or minus root 3 over 2? Well, it's pi over 3, 2 pi over 3, 4 pi over 3, pi over 3. It's all the pi over 3s, the 4 quadrants. Of course, plus 2n pi. We're talking about sine here, so we want to add 2n pi. That's what 2t is equal to, though. We want just t. We want to solve for t, so we divide all these through by 2. So pi over 3 divided by 2, pi over 6. 2 pi over 3 divided by 2, pi over 3. 4 pi over 3 divided by 2, 2 pi over 3. 5 pi over 3 divided by 2, 5 pi over 6. And then it's plus n pi, where n is an element of the integers. And that's our final answer there. Okay? Questions on any of that? Okay. So your assignment is up here on the board, all right? Again, page 394, 33, and then 39 to 43, the odds, and then 63, and then 91. Okay?
So we're coming here, how long are we coming here?
I have